So in this video, we're going to talk about how to find trigonometric derivatives just using a few building blocks. So assuming that we know that the derivative of sine of x is equal to cosine of x, and assuming that we know the derivative of cosine of x is equal to negative sine of x, we can use the quotient rule to find derivatives for the remaining trigonometric functions. In this video, I'm just going to be doing one of the harder examples, which is for cotangent of x. So to start, I'm going to find the derivative of cotangent of x. And my strategy is going to be to rewrite this in terms of sine and cosine, since that is derivatives that I already know. So this would be the same as the derivative of cosine of x over sine of x. And now that I have written cotan of x as a quotient, I want to use the quotient rule. So just a reminder of what the quotient rule states. It says that the derivative of two functions that we are assuming are differentiable, and where g is defined at 0, is equivalent to f prime of x times g of x minus g prime of x times f of x, and that whole quantity over g of x squared. So again, whenever I'm using one of these rules to help expedite the process of finding a derivative, I want to be able to visualize, what is my f of x and what is my g of x. So in this case, I'm going to say let cosine of x be my f, and let sine of x be my g. So in this case, I'll have the derivative of cosine of x over sine of x equal to the derivative of cosine of x times sine of x minus the derivative of sine of x and then times cosine of x. And this entire quantity divided by g of x squared, which is sine of x squared. So simplifying this, we know that the derivative of cosine of x is negative sine of x. So combining negative sine of x with sine of x, I should get negative sine of x squared. And then the derivative of sine of x is cosine of x, so I'm subtracting cosine times cosine, which would be subtract cosine squared of x. And this is all over sine of x squared. Now, at this point, all I would be thinking about is there any way that I can simplify this so I have an answer that is still equivalent but is maybe more palatable, something that I can easily remember? And the one thing that I do recognize is that I have a minus sine x squared minus cosine x squared, and this is pretty similar to one of the trigonomic identities that you might have learned in pre-calculus. And that identity is right here, sine squared plus cosine squared is equal to 1. So at this point, I can see the similarities between this, and I tell myself, okay, is there a way that I can incorporate this identity into my numerator so that I can have something that is more simplified? And in fact, if I pull out a negative here, I would be left with sine squared plus cosine squared. And just as a note for notation, putting the square outside sine of x and putting it inside, these are equivalent expressions, so I'll be using both of them in my notation. And at this point, now that I have rewritten this as sine squared plus cosine squared, I can replace this part with 1. So then I would have negative 1 over sine of x squared. And again, knowing some basic trigonometry, I know that I could break this into two pieces. So I have negative 1 over sine of x times 1 over sine of x. And this would turn into cosecant. So I have negative cosecant of x times cosecant of x. Altogether gives me negative cosecant x squared. So altogether, the derivative of one of the maybe more difficult trig functions of cotangent of x is equal to negative cosecant x squared. Okay, and by just knowing the derivatives of the basic trig functions sine of x and cosine of x, as well as utilizing the quotient rule, we should be able to find the derivative of any basic trig function.